All right, welcome back, everybody. So let's go ahead and finish these application examples. So we've got a bacteria, starts with 100 bacteria and then is doubling every hour. So then our population function is going to be 100 times 2 to the t. So at t equals 0, we'll have 100 bacteria and then we'll double every hour. So after how long will the population reach 10,000? So this is going to be pretty straightforward to solve. So we'll set our population equal to 10,000, divide by 100. So we'll get 100 is equal to 2 to the t. We can take the natural log of both sides. And then it looks like t is going to equal the natural log of 100 divided by the natural log of 2, which is going to be 6.643855619 years. Okay, so sometime into beyond the middle of the 7th year. So this will be years. And then it says find the rate of change of the bacteria after 3 hours. Oh, sorry, not years. Should be hours. So find the rate of change of the bacteria after 3 hours. So that's going to require us to find p prime. So p prime is going to be 100 times the derivative of 2 to the t, which will be natural log of 2 times 2 to the t. So p prime of 3 is going to equal 100 times the natural log of 2 times 8. Which is going to be 554.5177. And that's bacteria per hour. So that's the rate of change of our population of bacteria. All right. So let's see. Number 1, we're going to consider 2 scenarios. A deposit of $100 is made into an account with an annual rate of 5%. So it says write a function for the amount in the account after t years if it's compounded monthly. All right, so we've got our compound interest formula up at the top. So note compounded monthly means t is equal to 12. So and this should be n, since n is the number of compoundings. So determine the amount in the account after 5 years. So then a of 5 is going to equal, let's see. So P, our initial principal is $100. Our rate is 5%. Note the rate's going to have to be the percentage as a decimal. And then divided by 12. And then after 5 years, 12 times 5, so to the 60th. So this should be a quick calculator calculation. To the 60th. So looks like we're going to have $128.34 if we round. All right, and then if we compound it continuously, that's going to be using the A equals PE to the RT. So A of 5 in this case is going to be 100, and then E to the RT. So 100 times E to the 0.05 times 5. And lo and behold, what do we get? Something very similar. 128.402 0.025, so 40 cents. We'll round to the nearest cent here. So roughly the same, but the continuously compounded interest will be actually the optimal, the most interest that can be earned. All right, so 2 half-life for carbon is 5,730 years. If there's 20 grams of carbon 14, how much will remain after 15,000 years? So there's a couple of different equations you can use here. I think I put up this basic one with the base 1/2. So n of t is equal to n naught 1/2 to the t over k, where k is going to be the half-life value. So if we're using that one, then we've got 20 grams, so n of t is going to be 20 times 1/2 t over 5730. So then we'll just plug in 15,000 here. So 20 times half, 15,000 divided by 5730. So it's definitely going to be more than 3 halves. So let's see, or no, slightly less than 3 halves. So we end up with 3.258,317 grams remaining of our carbon 14. And then it says, what is the limit of the half-life function as t approaches infinity? So that would be the limit as t goes to infinity of 20 times 1/2 to the t over 5730. And really all we need to care about is what our function is doing. Is it decay or growth? It's clearly decay, which means the amount of our quantity is going to shrink to 0. Right, so it's going to get closer and closer to 0 as time passes on. For the half-life, there is a separate version of half-life. So that looks like n of t is equal to n naught e to the negative kt. And in that case, k has a slightly different value. So that's going to be the decay constant, which tells you kind of the decay rate. But typically they will give you the equation. So you won't have to memorize these equations again. So whether it's compound interest or half-life, you don't need to have any of these memorized. All right, and that finishes the notes for 5.5. So again, if you got questions, shoot me an email. Otherwise, come by my office hours. Till I see you next time. Take care.